So let's start with question 26. In this question, we have been asked to find out the total number of geometrical isomers. So how many systems are showing geometrical isomerism in this molecule? See, this is one system across which GI is possible. Okay. This is one system across which GI is possible. So already we have identified two systems showing GI. And also this ring is showing GI, which means the value of n is equal to 3. The total number of systems showing geometrical isomerism is equal to 3. Now, this molecule is unsymmetrical. So 2 raised to n will be the formula. 2 raised to 3. So 8 geometrical isomers are possible. In case you have not understood why the ring is taken as a system showing GI, I will explain it briefly. See, here you have this group and here you have hydrogen. Here you have this group and here you have hydrogen. Now, one isomer will be such that both the hydrogen atoms are on wedges, and one isomer will be where one H is on wedge and the other H is on dash. Hence, I am saying that this is also a system showing GI. So the ring has been considered a system showing GI, and there are 2 double bonds in addition to that. So in total, there are 3 systems showing GI, and the total number of geometrical isomers is equal to 2 raised to n, so 8. 27th question. Again, we have been asked to find out the total number of geometrical isomers. This is the molecule shown. Now, this is one system showing GI, this is another system showing GI. So the value of n is equal to 2. It's an even number. Now, see, this portion is same as this portion, which means the molecule is symmetric. If the molecule is symmetrical, then the formula is what? Total number of geometrical isomers will be 2 raised to n minus 1 plus 2 raised to n by 2 minus 1. And hence the answer is 3. Is answer. Question number 28. Question number 28. Okay. Now, this proportionation reaction is being talked about. So, sodium hydroxide and sulfur, if I take sodium hydroxide reacts with sulfur to form Na2S plus Na2SO3 and water. I'm not balancing it, it's not required. I'm just showing you how it is an example of this proportion. So here sulfur has an oxidation state of 0, here -2, here if I calculate it will be how much? +4. 0 to -2 is a mathematical decrease indicating reduction. 0 to +4 is a mathematical increase indicating oxidation. So I can say that sulfur has undergone disproportionation, and so the correct answer is sulfur. So sulfur reacts with NaH in this manner. Question number 29. The total number of stereoisomers possible. Okay. Now again, I have to find out the total number of systems showing stereoisomerism, wherein I'll see how many systems are showing optical isomerism. I'll see if there is any scope for geometrical isomerism. In this, there is one chiral carbon, there is one chiral carbon. Now this carbon becomes pseudo-chiral. Which means that the value of n is equal to 3. I have to count the pseudo-chiral carbon also, right? Now, this is a symmetrical system because this end is same as this end. Again, this portion is same as this portion. It's a symmetrical species, and this is an odd value of n. We know that when n is odd, there are two subcategories. One is where the middle part or the middle of the molecule contains a pseudo chiral carbon. And if the middle contains a double bond. These are the two subtypes when n is odd and it's a symmetrical molecule. So middle contains a double bond. This is not taken into consideration at the moment for this question because the middle contains a pseudo chiral carbon. So I will go for this. So 2 raised to n minus 1 is the formula to calculate total number of stereoisomers when the middle contains a pseudo chiral carbon, and so we get 2 raised to 3 minus. So 4 stereoisomers are possible. 30th question. Which of the following compounds decomposes at highest temperature? Now, there is another way of seeing the same thing. If I ask you which compound is most resistant to heat, which means has maximum thermal stability. And the compound having maximum thermal stability will decompose at the highest possible temperature. That means a very high temperature is needed in order to decompose it. Now, if you look at the options, there are 4 compounds given. They are carbonates of alkaline earth metals. We know that if the anion is polyatomic, like carbonate, sulfate, nitrate, anything which is polyatomic, then thermal stability is directly proportional to size of cation, which means barium carbonate will be the compound which decomposes at the highest temperature. Hence, the correct option is B. 31st question. The compound can be written in this manner. This is how I can write. Now, this is an alene because there are 2 consecutive double bonds. We know that an alene shows optical isomerism if these 2 groups are different. That means H is not same as COOH. Similarly, this side also, if you look at, H is not same as COOH. So I'll say that this compound can show optical isomerism, which means that there are 2 optical isomers. Hence, A is the correct option. Please note well, this cannot show geometrical isomerism. When the number of consecutive double bonds is even, then geometrical isomerism is not possible. But here, optical isomerism is possible. Optical will be possible when these 2 groups are different and also these 2 groups are different. Both the conditions need to be met. I will again repeat this. This is optically active if A is not equal to B and C is not equal to D. So then I say that this has 2 optical isomers. Hence, A is the correct option. Next question. Now, this is a cyclic process. If you look at this carefully, A to B is isobaric because the pressure is constant. but the volume increases, which means VB is greater than PA. Okay. Then B2C. B2C. B2C is what? B2C is isothermal process. It's a curve. C2D. C2D is isochoric, as volume is constant when the process goes from state C to state D. C to D we have done, now D to A. D to A again is isothermal. It's a curve, right? Which means if I plot a graph between V and T, then from A to B is isobaric. Now see, A to B is isobaric, but VB is greater than VA, which means that the volume has to increase. Also, according to ideal gas equation, we know that volume is proportional to temperature if pressure is constant, which means temperature also has to increase. So TB is greater than TA. Hence, this will be the kind of line obtained. You can clearly see that TB is greater than TA here. Also, VB is greater than VA here. Then it's isothermal from B to C. So this is how I can represent. It's a line parallel to the y-axis, that is BC, indicates that the temperature is constant. Then C to D is a line parallel to the x-axis, which means that the volume is constant. We have already assessed here, and we know that the volume is constant when the process moves from C to D. And then D to A is again isothermal, so there is a line parallel to the y-axis. Hence, this should be the correct answer. So C is the correct option. 33rd. N-octane. Now, what is N-octane? C8H18. Let's write the equation for combustion. This is the equation of combustion. I'm taking standard states, which means O2 has to be taken in gaseous form. Octane has to be taken in the liquid form, right? Because in the question they have mentioned that octane is in the liquid form. Since in the question they have mentioned that octane is in the liquid form, I have to take octane in the liquid form itself, and hence I write L. We know that the products of combustion are CO2 and water. H2 has to be taken in the liquid form because standard states need to be considered. I need to balance the chemical equation. 1 mole of the reactant must be taken because it's standard enthalpy of combustion that they are interested in. So 8 CO2 and 9 H2. Let's balance oxygen atoms on the left hand side. On the right hand side, if you look carefully, then there are 16 plus 9, 25 oxygen atoms. Hence, here I write 25 upon 2. Now, delta H is equal to delta U plus delta Ng RT. Delta U is also called delta E. Let's put the values. Delta Ng is how much? 8 minus 25 upon 2. R will be 8.314. I'm using SI units. So joule per mole per Kelvin is the unit of R. Temperature is 298 Kelvin. If I compute this, I'll get the value in joule per mole. And if I divide this by 1000, I'll get the value in kilojoule per mole. So if I compute this, then it's equal to minus 11.15 kilojoule per 34th machine. All right. Now they have asked us to express the enthalpy of formation of NCl3 in terms of delta H1, delta H1, delta H2. For NCl3, I mean for the formation of NCl3, I should write this equation. Correct. So this is my target equation. That means I want to arrive at this. Now see, how do I arrive at this? There are three equations given to me. 1, 2, 3. Although they have not numbered, but now I am numbering for the sake of convenience. 1, 2, and 3 are the three equations given. For 1, the value of enthalpy change is given as minus delta H1. For 2, the value of enthalpy change is given as delta H2. And for 3, the value of enthalpy change is given as delta H3. Now, if I want to arrive at the desired equation, then I need to keep the first equation as it is. I need to multiply 1 by 2. It means I need to divide the second equation by 2, and then I need to subtract 1.5 times the third equation. Then only I'll get the desired equation. That means equation 1 plus half of equation 2 minus 3 by 2 into equation 3. If I perform this operation, I'll get this equation. And hence the correct answer is this, which is option A, 35th. 35th question is again based on Hess law, just similar to the 34th. But now we have been given values, so we need to substitute the values and then compute the final answer. So we are interested in this equation. It is the desired equation is N2H4 hydrazine. 1 mole of N2H4 has been taken. I mean, it needs to be taken because standard enthalpy of combustion is being talked about. O2 has to be in the gaseous form. In the question, I have mentioned that N2 is one of the products and H2O is another product. I need to balance this equation. Now it's a balanced chemical equation. Let this be my target equation and let me call this equation number 5. Why am I calling this 5? Already 4 equations are given in the question. So let this be equation 5. Now if I want to arrive at equation 5, I will divide the first equation by 4. Then I will do this, that is minus 1 by 8 into equation 3 minus 3 by 4 into equation 2 plus 9 by 4 into equation 4. If I perform this operation, I will get the 5th equation. That means I will get this. The first equation is given in the question where you see N2 on the right hand side. I divided the first equation by 4 because I want N2 to be on the right hand side, but I want the coefficient of N2 to be 1. You can look at this clearly. In my desired target equation, the coefficient of N2 is 1. In order to make the coefficient of N to 1, I have divided the first equation by 4. Okay. Then in that process, the coefficient of ammonia becomes 2 upon 4. 2 upon 4 is 1 upon 2. That is in the first equation itself. But 1 upon 2 NH3 is not desired because in the final target equation, we don't see any NH3 appearing, which means I have to do away with NH3. If I have to do away with NH3, I need to somehow cancel it. 1 by 2 NH3 is appearing on the left-hand side when I do 1 by 4 into equation 1. So 1 by 2 NH3 should appear on the right-hand side as well somewhere. Where do I see NH3? I see NH3 in the third equation, but then I see there in the reactant side. Hence, I did a subtraction. This minus indicates that I have reversed the equation. So NH3 will go on the right hand side. But I have to divide by 8 because I want to make the coefficient of NH3 1 by 2. So 4 upon 8 is 1 upon 2. So 1 upon 2 NH3 appears on the right hand side. And so 1 upon 2 NH3 gets cancelled with 1 upon 2 NH3 of the first equation. So in this way, I managed to arrive. Similarly, I will do the other operations as shown. And if I do these operations, I will get the final desired equation. So the value of delta H5 will be 1 upon 4 into delta H1 minus 1 upon 8 into delta H3 minus 3 upon 4 into delta H2 plus 9 upon 4 into delta H4, which is equal to 1 upon 4 into minus 1011 plus 286 upon 8 plus 3 by 4 into 317 minus 9 by 4 into 285. On solving this, answer is minus 620.5 per mole of N2H4. Question 36. Acid-base reaction takes place between HCl and KOH. So I can write this reaction. We know that KOH is a strong base, HCl is a strong base. Now see, in the question they have mentioned that 500 ml of 2 molar KOH has been taken, which means 500 upon 1000 into 2, which means 1 mole of KOH has been taken. Similarly, 1 mole of HCl also has been taken because again 500 upon 1000 into 2 is equal to 1. When 1 mole of HCl reacts with 1 mole of KOH, 1 mole of KCl is formed and 1 mole of H2 is formed. KOH and HCl are completely consumed and 1 mole of H2 is formed. Now we know that the enthalpy of neutralization for a reaction between a strong acid and a strong base is given in this manner. That is delta H is equal to minus 13.7 into number of moles of water formed. Now, this formula is applicable only if both acid as well as base are strong, and the unit for delta H in this case is kilocalorie. How many moles of water have been formed? 1 mole of water has been formed here. So minus 13.7 kilocalorie is the value of delta H in case 1. What is case 1? Case 1 is the situation in which I have taken 1 mole of KOH and 1 mole of HCl. Now, in the question, they have talked about case 2, wherein there is an acid-base reaction between KOH and HCl, but now the volume of acid is different and also the volume of base is different. Reaction remains the same, that is this KOH plus HCl given KCl plus H2O. 250 ml of each solution has been taken. So 250 into 2 molar, 250 upon 1000, that is 250 upon 1000 liters into 2, that is equal to 0.5 mole of KCl and 0.5 moles of, 0.5 moles of KOH and 0.5 moles of HCl. 0.5 moles of KOH will react with 0.5 moles of HCl to form 0.5 moles of KCl and 0.5 moles of water. Again, I will say the enthalpy of neutralization in this case in kilocalorie will be minus 13.7 into number of moles of water formed, that is this. Now see, I can clearly say that delta H1 is 2 times delta H2. Compare this value and this value. So delta H1 is 2 times delta H2. Now also we know that here the enthalpy of neutralization, that is equal to the heat which is absorbed by the solution. In the question they have mentioned that assume all heat is taken by the solution. Now, whatever enthalpy of neutralization is obtained, that means whatever energy is released as a result of neutralization is completely absorbed by the solution in each case. Now, the volume of the solution in case 1 is 1000 ml because 500 ml of acid and 500 ml of base were mixed. Volume of the solution becomes 1000 ml. Density of solution is not known to me. Let it be rho grams per ml. And the rise in temperature is T1. So into heat capacity of the solution, let it be C. So MC delta T is what I have. So difference in temperature, the rise in temperature is given as T1, that is delta T is T1 in this case. Mass of the solution is volume into density and heat capacity is C. So this is nothing but equal to, I can say, delta H1 because whatever energy has been reduced, that same amount of energy has been absorbed by the solution. Similarly, in case 2, I can say that 500 ml is the total volume because 250 ml of acid was mixed with 250 ml of base. Rho, again, density of solution. Density is an intensive property, so that value will remain the same. And now delta T is T2. Heat capacity of solution will also remain the same. Okay. Since it's taking place at constant pressure, straight away I'm saying that Q2 is equal to delta H2 and Q1 is equal to delta H1. Now clearly we have seen that delta H1 is equal to 2 times delta H2. That means Q1 is equal to 2 times Q2. Now we can use this relation. So 1000 into rho into C into T1 is equal to 2 into 500 into rho into C2 into T2. To C. Specific heat capacity of the solution won't change. That's an intensive property that will remain the same because the same chemicals have been used. From here, we can clearly see that T1 is equal to T2. What was T1? The change in temperature in case 1. What was T2? The change in temperature in case 2. So option A is correct. Coming to 37th question. Now, in the 37th question, they have given a graph of pressure versus temperature. Here, the value of pressure is 2 into 10 plus 2, 5 Pascal. Temperature here is 300 Kelvin. Temperature here is 500 Kelvin. Correct? Okay. Number of moles is given as 2 moles of gas. It's an ideal gas. And they have asked us to calculate the value of work done by the gas and taking it from A to B, which means that we have to focus only on the path AB. We don't have to look at B, C, C, D, or D, A because work is a path function and we are interested only in AB. Because the question has clearly stated that They want us to find out the work done when the process is from A to B. Work done is equal to minus P delta V. Now, how can I use this formula directly? I'm using this formula directly because the value of pressure is constant when the process moves from A to B. That means I can consider it to be an isobaric process. The pressure is 2 into 10 raised to 5 Pascal. Hence, I have used this form. So minus 2 into 10 raised to 5 Pascal. SI units need to be considered. I'm considering SI units. Delta V is V2 minus V1, which means it is VB minus V. Now, what is VB? Using ideal gas equation, I can say that VB is equal to nRTB upon PB. And similarly, I can write VA in this manner. But we saw that PA is same as PB, and that is 2 into 10 raised to 5. Because A to B is isobaric. Okay. On solving this, I can say NR comes out, and this becomes TB minus T. Number of moles is 2. Let's keep R as it is because the answers also are in terms of R. TB is 500, TA is 300. This becomes minus 400 R. If R is taken as 8.314 joule per mole per Kelvin, then the value of this work done will be in joules. Anyway, so work done is equal to minus 400 R, that is from A to B. And hence I can say that work done by the gas, because when I use the word by, I have to write only the magnitude, and so this becomes the answer. Okay. Question number 30. PV to the power of 2 is equal to K1 and PV is equal to K2. Expansion is taking place, they have mentioned it. Now this is nothing but isothermal, that is a reversible isothermal process. This is a reversible adiabatic, similar to adiabatic, or you can say polytropic. Polytropic. Now see, if I draw a graph of P versus B, I can say that this is my starting point, then this curve is obtained when it's an isothermal process, and this curve will be obtained when the process is adiabatic or polytropic. Here they have clearly mentioned that the values of pressure and volume are not in perspective. Okay. I have to show the arrows in this direction. Why? Because expansion is taking place. Now clearly I can see that the area under the curve is greater if I consider the isothermal process, and the area under the curve is less if I consider the polytropic process. And what is area under the curve? We know that in case of expansion, area under the curve is equal to magnitude of work done. So don't just say work done. You need to say that area under the curve is the magnitude of the work done. Magnitude of work done is greater if the process is isothermal. If the process is isothermal, that means I consider that the value of work done in the second process is greater in the above expansion, irrespective of the values of K1 and K2. If I'm talking only about magnitudes, hence C is the correct option. 39th question. There are two samples. Okay. There are two samples. So first sample. Here I can say that P1 V1 is equal to P2 V2 because they have mentioned that it is a reversible isothermal process, wherein the final pressure is half of the initial pressure. So P1 V1 is equal to P1 upon 2 into V2. Hence V2 is equal to 2 times V. So this is for first sample. In the second sample, I will say P1 V1 to the power of gamma is equal to P2 V2 to the power of gamma. Why? Because it is a reversible adiabatic process. Again, I will put P2 as half of P1 because they have mentioned that the pressure is half of the, the final pressure is half of the initial pressure. And from here, I can say that V2 is equal to 2 raised to 1 upon gamma into V1. We know that gamma is always greater than 1. Like for monoatomic, it's 5/3. For diatomic, it's 1.4. Right. So every time gamma is greater than 1. Hence, 2 raised to 1 by gamma will be less than 2. So I can say that final volume in case of second sample is less than final volume of the first sample. Hence option B is correct. 40th question. Work done by the gas. Now see, again I'm repeating. If this thing is mentioned by the system or by the gas, then focus only on magnitude. Ignore the signs, which means only area under the curve. Right? Only area under the curve. So here, this is first sample because it's isothermal. This is second sample because it's adiabatic. So I can clearly say that work done by the gas is greater in the first sample. So work done by the gas in the first sample is greater than the work done by the gas in the second sample. Hence option A is correct. 41st question. The equilibrium constant is given. So K is given, which is 10 raised to temperature is 300 Kelvin. What is the value of standard free energy change? Delta G naught is equal to minus 2.303 RT log K. This is the formula. Delta G naught is standard free energy change. Put the values in SI units. R is 8.314. Temperature is 300 into log 10 raised to 20. Correct. In joules, I will get the answer. But options are in kilojoules. So let's divide this entire thing by 1000. Hence, I'll get the value. If you compute this, you will get yeah, so you can find out the value. Okay. So you'll get the answer as minus 115 kilojoules. I mean, if you look at the options. Next question. 40 seconds. 40-second question. Okay. I have diamond. And graphite. Densities are given. Now, if I want to find out the molar volume, of, let's say, diamond will be how much? Molar mass upon density. Density is given as 3.5 gram per cc. So this will be the molar volume of that. Similarly, molar volume of graphite. Molar volume of graphite is equal to 12 upon 2.3. So I can see clearly that the molar volume of graphite is greater than the molar volume of diamond. Now, if I increase the pressure, if I apply more pressure, then what will happen? So the equilibrium will shift as per Le-Chatelier's principle. The equilibrium will shift as per Le-Chatelier's principle. If I apply pressure, then the equilibrium will shift towards diamond because the molar volume of diamond is less. So I can say that the backward reaction will be favored if I apply more of pressure. So on increasing pressure, the process that occurs is backward. That means more and more of diamond will be formed. Hence, option A is correct. This happened because the molar volume on the left-hand side is less than the molar volume on the right. So remember, if I apply more and more of pressure, then the system wants to shift to that direction where the volume is less. Just like you have ice water system, if you apply more and more of pressure, then the equilibrium shifts forward. Why? Because molar volume of water is less than the molar volume of ice. 43rd question. It's a little controversial question. So C and B both are accepted as correct answers. 44th. Kp is given. We know that Kp is equal to Kc into RT to the power of delta G. Kp is given as 1.7 into 10 raised to 12. R will be 0.082. Temperature is given as 220 degrees Celsius, that is 293 Kelvin. Delta Ng. Delta Ng is how much? 1 minus 1.5. 1 minus 1.5. That is minus 1. So 1.7 into 10 raised to 12 is equal to Kc. Into now 0.082 into 293 has to be calculated. 24.026. Let's approximately take this as 25 in order to simplify the calculations. So 1.7 into 10 raised to 12 is equal to Kc into 25 to the power of minus 1. I took this because I wanted to simplify the calculation. 1.7 into 10 raised to 12 is equal to Kc upon root 25, that is 5. This is what I will. Let's choose the nearest option. So you have 8.4 into 10 raised to 12, and C is correct. Question number 45. Question number 45. Now, what is question number 45 asking us to do? Now, here I have a graph. If graph goes like this, the process is endothermic. If a graph goes like this, then process is exothermic. For an endothermic process, we know that if temperature is increased, then the equilibrium constant also increases. Hence, A is the correct option for 45th question. 46th. How many chiral centers are present in the following compound? Now see, this is one chiral carbon, this is the other chiral carbon. So 2. So 2.00, because it's a numerical type question. 47th question. How many chiral centers are present in the following compound? I need to draw this in order to give you the full clarity. Some of you must have gone wrong in this. Hence, I will draw and show all the chiral centers. Okay. I will indicate the chiral carbons with the help of a red color. Chiral carbon. This is another 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 chiral carbon. And this one is another. So you can count 1, 2, 3, 4, 5, 6, 7, 8. So 8.00. 48. It's a nice question. I want to cool 500 grams of liquid water from 20 degrees Celsius to 0 degrees Celsius, which means heat to be lost. If something is getting cooled, it's losing heat. Heat to be lost is equal to how much? 500 upon 18 moles of water, because 18 is the molar mass of water, into molar heat capacity of water is given as 75.6 joule per mole per Kelvin. Delta T will be 20 minus 0 degrees. Delta T will be 20. Delta T is same in Kelvin as well as in degrees Celsius, so it doesn't matter. This will be the value in joules. Yeah, joules. Okay. Now, if this heat is lost, it needs to go somewhere. Now, when water is getting cooled, That means it's losing heat, and that heat is getting absorbed by ice cubes, because in the question they have mentioned that ice cubes are placed. So heat to be absorbed by ice cubes will be equal to 6,000 into X joules. 6 kilojoule per mole is the latent heat of fission of ice. So I've taken it as 6,000 joule per mole. Let X be the moles of ice in ice cubes. Hence, I can equate heat loss and heat gained. 6,000 X is equal to 500 upon 18 into 75.6 into 20. On solving this, X is equal to 40. Sorry, X is equal to 7. Okay. Now see, in the question they have mentioned that each ice cube contains 9 grams of H2. Now 9 grams means what? 9 by 18 moles, that is 0.5. So one ice cube corresponds to 0.5 moles. Therefore, n ice cubes correspond to 7 moles of ice. And if I cross multiply, I'll get n as 14. So 14 ice cubes are required. Forty-ninth one. Okay. Conversion of 1 mole of graphite to 1 mole of diamond. So C graphite to C diamond. Okay. And they have asked us to find out delta U minus delta H. We know that delta H is equal to delta U plus P into V2 minus V1 if pressure is constant. In the question, they have mentioned that the pressure is constant and the value of pressure is given as 5 into 10 raised to 5 bar. From here, I can say delta U minus delta H is minus P into V2 minus V1. Minus P into V2 minus V1 will be equal to minus 5 into 10 raised to 5 bar. V2 is what? Volume of 1 mole of diamond, because diamond is on the right hand side, so that has to be V2. Volume of 1 mole of diamond will be what? Molar mass of diamond upon density. Molar mass of diamond will be 12 grams per mole, because 1 mole of diamond means 1 mole of carbon. So 12 upon density is given as 3 grams per cc. So I'll get the molar volume of diamond in centimeter cube. Similarly, molar volume of graphite in centimeter cube will be this. Centimeter cube can be converted to liter by multiplying by 10 raised to minus 3. And so this entire value will be in bar liter, because pressure is in bar and the volumes have been taken in liters. So bar liter. If I solve this, I will get minus 5 into 10 raised to 5. 4 minus 6, that is minus 2, into 10 raised to minus 3 bar liter. Minus minus cancelled, so 5 into 2, 10 into 10 raised to 5 into 10 raised to minus 3 bar liter. In the question, it's mentioned 1 bar liter is equal to 100 joules. So let's multiply this by 100, so we get the value in joules. But they've asked us to find out the value in kilojoule per. So I divide this by 1000. Now it is in kilojoule. So this, which is equal to 100 kilojoules. So answer is 100. Since it's a numerical type question, you are supposed to write like this. 50th question. Okay. Now see, in this question, they have given us a reaction. And they have asked us to find out the value of degree of dissociation of SO2Cl. SO2Cl2 dissociates in this manner. Correct. Let the initial pressure be X atm at equilibrium. Let the pressure be X minus P atm. I mean, the partial pressure of SO2Cl2 is X minus P atm. The partial pressure of SO2 will be P atm. The partial pressure of Cl2 will be P atm. All right. It's mentioned that the total pressure at equilibrium is 1 atm. So X minus P plus P plus P is equal to 1 atm. From here I will get X plus P is equal to 1. Partial pressures have been added because we know that the sum of all partial pressures is equal to the total pressure. Okay, now Kp has been given. So I can say that Kp is equal to partial pressure of SO2 multiplied by partial pressure of Cl2 upon partial pressure of SO2Cl2. So P into P upon X minus. So P into P upon X minus. Kp is 0.029. So I can say that P square upon 1 minus 2P is equal to 0.029. What have I done basically? I have taken X as 1 minus P because we know that X plus P is equal to 1. So I have converted X in terms of P. And hence I get this. This is a quadratic equation. So P square plus 0.058 P minus 0.029 is equal to 0. P is equal to, I can use the formula to find out the roots of a quadratic equation. From here, I will get this kind of expression. Hence, P is equal to, on solving this, I will get the value of P. That is 0.143 atm. Okay. Degree of dissociation is alpha, which is P upon X. What is P? The amount of pressure that is born, which is reacted. What is X? The initial partial pressure of SO2. So P upon X is going to be the degree of dissociation. Put the values. P will be 0.143. X is 1 minus P because we know that P plus X is equal to. On solving this, the value is 0.167. Hence, alpha is equal to 0.17. Rounding off is necessary here because I need only 2 digits after the decimal. So alpha is 0.17. I hope you have understood all the solutions. Still, if any doubt persists, you may get in touch with me on WhatsApp. Okay, thank you.